everybody. In this video, I want to show you some options that you have if you want to construct objects that have a lot of different things that you could set about them. So particle doesn't have that many things, but we might want to construct particle the way we are here, just with a position, and the velocity and acceleration start out with 0, and the size starts out at some default size. So in that case, you can just have one constructor, no problem. Well, what if over here we are constructing a particle and then we're setting the velocity? What if instead we wish that we could do this? Let's make our velocities, and then instead of using a setter, could we just pass the two velocities as parameters? X velocity, Y velocity, like this. We could do that if we change the constructor, but maybe we don't want to. So if we change the constructor here to have like X velocity and Y velocity, and then we set velocity to X velocity, Y velocity. Okay, so if we do that, now the problem is maybe we don't want to always have to pass 0, 0 if we're only creating particles at a particular position. So the problem with one constructor is that it forces you to use all those inputs every single time. So one solution would be, let's overload the constructor. So let's have one constructor that only takes 2 parameters. Here. And then, oh, actually, hold on. So it'll take I should say it takes 2 arguments, it takes 2 inputs of X and Y, and so you'll use that to initialize the position. And the velocity will just be default 0. Or you could have this overloaded constructor, which takes 4 inputs, the position and the velocity, but acceleration and size are still 0. And then we could create another overloaded constructor that takes position, velocity, and size. And so now you could initialize size to be the argument there. So this is totally possible. It's a very common option. You see it a lot in Java programs. It's a little bit clunky because it's just not nice to have so many kind of repeated constructors that have a lot of repeated code in them. But as I'll point out, you can definitely use them. So here I'm creating particles with velocities, but if I wanted to, I could totally create a particle with just an initial position, and that's all. Another disadvantage here, though, is it's not very flexible. So let's say I wanted to create a particle just at a certain position and size 400. Well, if I'm going to do that, I'm forced to use the constructor where I specify the velocities. So this overloading of constructors gives you some flexibility, but not a ton of flexibility. So a different option would be, let's just make sure that we have setter methods for all the things we want to set. So here I've got set velocity, set size, and then whenever you create a particle, you just use the one constructor, and you set the velocity and the size. And that's okay. There's nothing super wrong with that. If there were a lot of things that I wanted to set, though, it would be a little bit irritating to have to run like 5 lines of code every single time I want to just create an object, but also have control over how it gets initialized. So a different option would be a modification to your setter methods that would let you chain all the setters together on one line. So let me show you what that looks like. So let's do set size. So right now, set size takes a new input size and sets it, but it's a void method. What if we return a particle object, and the particle object we return is the object that just got set? What this lets us do is when we create a new particle, this part here, running the constructor returns a particle object. So we can immediately run a method on it. So we could run set size, and we could set the size to 3. And so far, that doesn't seem that interesting. But let's do the same thing for set velocity. So I'm going to return a particle, and it's going to return itself, the particle that just got set. And so now, after I run set size, this is returning the same particle that just got set. So I can run another method on it. I can set the velocity. So let's set it to 0, 10. So this is what I mean when I say chaining chaining setters together. You can run one setter after another. And what's nice about this is you can have as many of them or as few of them as you want, and you can run them in any order that you want. To avoid having something that's too long on one line, you might choose to rename some of them. So let's rename this one. Let's just rename this one to size, and let's just rename this one to velocity. Oh, I haven't overloaded, and so it was asking me, did I want to do the same thing for the overloaded method? So naming them shorter names makes it a little bit nicer. If you're worried that you can't tell the difference between, like, am I trying to set the size or am I trying to get the size? Again, you can use method overloading to solve this. If I'm running size with an input, it must be that I'm trying to set the size. You could also have a method, which was just called getSize if you wanted to, or you could have a method where it's just size with no input, and in that case, I must be trying to get the size. So you can dispense with the names get and set, and you can just use whatever it is that you're trying to get and set, but then the way the class knows which methods you're trying to run is it pays attention to whether or not you're trying to give it an input or not. So that's chaining setters. It's also a very common pattern, kind of a cool one. You should definitely try it out, and then after this project, you can decide whether or not you want to use it.